Hi there, I'm Rob Shakir, as it says in the slide, and from Cable&Wireless. I work in the kind of designer and architecture type role, and one of my key focuses at the moment is into protocol resilience and error handling. And this talk's based off an IETF internet draft that I put together that kind of describes from the operator's point of view what the requirements are for BGP error handling and how we make this protocol kind of as robust as possible, and we get rid of some of the headaches that we've perhaps been experiencing as operators. So the kind of intention of today is a draft tends to be quite a heavy document. It's to try and stand up here and talk you kind of through what the draft says, what the idea behind it is, and to make sure that we get basically the operational community thinks that I'm not saying this. The things that I'm saying are actually accurate, and the things that I'm saying are what reflects our reality. Because there's a big split between the IETF and the operational communities in some ways. The operational communities tend to be easy to get involved with, maybe from an operator's point of view, and the IETF's got a lot of process. So it'd be really great to get a lot of to get feedback from you guys, and there's a feedback form at the end. So I'd really appreciate it as much as possible. But the structure of the talk is to go through the draft and explain perhaps some background. So I'm going to start off with a couple of diagrams, and this is really because at the start of the RFC that describes BGP, it says BGP4 is an inter-autonomous system routing protocol. So I want to look at the way that maybe this kind of implies your network probably looks. So is this a typical SP network? I don't think so, but what it had, I've used some MPLS terminology here for node names, so just ignore it. I just want to kind of point out that there's some core boxes, there's some edge boxes. And in your core, you've probably got an IGP that you're carrying your, in this view, you'd be carrying your customer information in, you'd be carrying your infrastructure prefixes in, and you'd be carrying any information that told your network that was relevant to the internals of your network, so how to get to different exit points. When you then were connecting with another company or another peer or another network, you would use some exterior gateway protocol, and that was you either redistribute the bits that you needed out of your IGP back into the exterior gateway protocol that then lets you propagate the routing information that you need out to the other autonomous system. And this is really, I think, the kind of view that BGP was built looking at, because this is how it worked before. But I think your modern network maybe looks a bit more like this. We've got a lot of changing requirements. We really need like a really quick to converge IGP, because we've got now the convergence requirements for what we're carrying on IP are a lot more strict than they were before. And so what we have in the IGP, instead of having this all this routing information that told us how to get anywhere out of our domain, we just really have some information that tells us this is our domain. We've got reachability information from each PE, tells it, or each node in the network knows how to get to each other node in the network. And we might have some really core infrastructure prefixes like your management or your authentication servers and that kind of thing. But really, probably most prefixes are not in your IGP anymore. It's as small as possible, because then it converges as quickly as possible. And so we then look at, well, what are we now using internally to propagate information? And pretty much the answer is BGP. So there's, as we've kind of overlaid more services onto the network, we've started to look at, okay, actually we'll have this routing protocol that we're running already, so let's use it internally and let's propagate service information, so VPNv4 maybe, and other topologies in this protocol. And what this has really given rise to is a big change in the way that maybe BGP looks in terms of how it's implemented. Because we've now got in this example I've got a route reflector, but it doesn't have to be. We've got techniques to kind of scale IBGP. And what that means is that you maybe looking at sessions that are now taking much more importance, because they're carrying all the information that's for every service in your network. And the reason that's important is now, if these sessions break, your network probably doesn't have any services. Great, it knows how to get around the inside of it, but it doesn't know how to get to run any of the services, the actual things that some customer is paying you for. So really, I think the kind of my key point here is that you run BGP as your IGP in some ways. You run all the service information is now propagated in that kind of in that kind of manner. And the IGP is really just to bootstrap BGP. As soon as you've got BGP up, then that's where the useful routing information is there, and your IGP just handles failure cases inside your network. So I want to talk about, obviously I'm talking about error handling, and I want to talk about why is this actually an issue? Why am I up here talking about it? Because if we had errors and we didn't have a problem, then I wouldn't be here, right? Because I wouldn't be wanting to try and talk about how we should change it. So I've picked out a few events. It's not an exhaustive list. It's more a list of ones that I think are notable. So this is the one. The first one is to do with the 4x attribute. So this was introduced. It's an optional transitive attribute that was introduced to carry 4-byte routing information across networks and across systems, BGP speakers that did not have support for it. And what happened in January 2009 was that Cisco released some code that had a strict implementation of the RFC. It said if you see a confederation set in the 4x attribute, then you should tear down the session. Well, you should handle this as an error. And unfortunately, there was a Juniper bug that was copying this information in, and some autonomous system somewhere didn't have a border box that ran 4x code, so it never got removed. And what was really noticeable about this is that this is in the internet. So, and it turns out that lots of people weren't running code that did 4x support. So what you ended up with was a prefix that had an attribute on it, where the attribute propagated quite a long distance. And as an autonomous system on the internet, you're much more likely to see a prefix through your transit provider than you are through a peer or so, because of the fact that you've got a transit session with all the table on it. And what this meant was that when the error was handled, it was handled by your ingress system towards your transit provider's router. And the mechanisms of the protocol meant that tore down the session. So if you'd run this code on all your border boxes, you could very easily isolate yourselves from part of the internet. The second one I want to talk about is to do with ASPath. We've seen a few of these, and they tend to be for differing reasons. But the key one that I want to talk about is I think it was a microtick bug, which when it was implemented, it meant that instead of getting I think that basically the problem was the prepend mechanism was inconsistent, and you ended up with these ASPaths that were hundreds and hundreds of ASs long. And I think there's even a site, I think, that tracks how really long ASPaths and whether they look like this bug. And what happened was this update came in with a really long ASPath attribute, which is now well-known mandatory. It's something we need to make a routing decision based on. So it's now really important that this information is correct, because if it's not, we can't make a routing decision properly. And what happened was it was a receiver-side bug, and the iOS boxes that received it couldn't actually pass it incorrectly, and couldn't pass the fact that this ASPath was so long, and tore down the session. So again, another attribute that comes in via your transit provider, and it was only if you had that iOS implementation that was buggy were you going to see this. So again, it's the sessions that failed could have been internally to your network, but they could have also been in your transit providers or a peer where that was important to you. And the notable thing is one prefix that needs this, not the whole table. The next one I want to talk about is it's actually much more recent, and this one to me is why this indicative of why this is a big problem for us. Because RIPE NCC and Duke University decided they wanted to do an experiment. It's fine, it's the default free routing table. You can use that. You do an experiment on it if you'd like. And what they did is they introduced an optional transitive attribute that had no meaning, that was 3,000 bytes long or so, I think. And what happened was that there was actually a bug in terms of how iOS XR propagated this update. So that they announced it at AMSIX, and so your edge box at AMSIX would receive this prefix with this attribute on that doesn't mean anything. We're not making any routing decision based on it, and announced it back into your network in a buggy manner. So whatever was peering with your border box internally tore down the session. And that could be that was from your root flag to your border box, and your border box might not just be doing IPv4. So you affected every prefix on that session and every address family because of an experimental prefix that you didn't even, if you didn't have it, this is no impact to you at all. And I think that unfortunately, I think there's a slight openness problem, but the last point is the most important, because there are failures in iBGP. We get lots of them, right? There are some, and we know that networks have had them. And there are definitely occurrences within service provider networks, but we can't have an exhaustive list of them because it's kind of not published. Nobody wants to stand up and go, well, this happened because there was a bug in this BGP implementation, and then this happened, and this happened. So, but these failures cost you a lot of money. They're where you make likely inside your AS, you're charging your customers more for that service. You're doing maybe an overlay service, or you've got a much bigger customer estate. It's not just, say, one transit connection or so. So these kind of failures are really do impact people's networks and do cost operators a lot of money. So why does this happen? I've kind of talked okay, we see session teardown, but why is that? So this is a really simplified view of what's happening. If you get an update that you think is erroneous, it doesn't have to be erroneous, but you think it is, then the only mechanism in BGP at the moment to be able to notify the peer on the other side is to send a notification packet. And in 4271, RFC 4271, it says, if you send a notification, you must tear down the session. So you're saying, this was an error, I want to tell somebody about it, but the thing that you've got to do then is you've got to tear down the session. And there is some utility in this, and I'll come back to why there is some utility in it. Especially in terms of limiting the scope of these invalid updates. But in a lot of cases, this is maybe this is really suboptimal, I think. So to just kind of summarize this section, and this is like the justification for why we want to look at this mechanism, see whether it's going to change, is the cause of the issue is really that there's a limited tool set in the standards. At the moment, you've either got to discard an attribute that you thought was erroneous, or discard the update with all the implications of that, or you've got to respond with a notification. It's not that there's an implementation that's just ignoring the fact that there was a more flexible way to do it. Actually, there isn't a more flexible way to do it at the moment, and for us to be able to amend that, we really need to have one. And the thing that I'm trying to get across is that the service impact of these session teardowns is massive. Could be a transit or peering failure, which gives you significant problems in terms of reachability. Even if it doesn't give you actual issues in terms of not being able to reach something, it might give you issues in terms of not being congesting paths that maybe are engineered quite finely also. And where we've got IBGP failure, the impact can be really serious. It can be that you get a session from your route reflector an update from your route reflector that then fails connectivity to all your PEs in a region, or all your PEs that fail that peer with that route reflector. And the kind of key point is coming back to this fact that I said I think you're using BGP as your IGP in some ways to propagate your customer routing services over your network. You really wouldn't tolerate in your IGP that if there was one erroneous packet that you dropped all adjacencies, or all routes that would go via that node. It just would not, it's unthinkable. So the robustness requirement is really different when you look at how BGP is being used. So what's the intent of what I'm trying to do and what I'm working with people to do? I think the thing is, in the IETF there's a lot of implementers, there's a lot of vendors, but there's not that many operational people. And where there are operational people, you've got to look at, are they operational people who are hired by an operator to do standards work? Or are they people who've used boxes? Is it someone that's typed at a router in the last 2 years or 5 years or however long it is? So I think we need to define how we use BGP and to make sure that we've documented what the critical nature is. And unfortunately, we don't really have a framework ourselves to be able to, as an operational community, to write a document that says that. The best thing we have is the IETF standards process, and they've got a standards process, so let's go and use that. And then I think we need to provide the requirements of what we want, because there's two camps. There's a robustness camp and then there's a protocol correctness camp, and you can't satisfy both at the same time. You have to make some compromises in both of them. So we want to have to look at what we'll compromise on and define why we'll compromise on it, why we don't think it's an issue. And then the other thing is there's a lot of disparate work in the IETF often, so that there might be this draft over here and another one over here that really, as an operator, one of them doesn't go unless we've got the other one, because we can't, it's very typical of monitoring things. You might implement a feature, but if we can't monitor the feature, then it becomes really difficult for us. So I want to tie together the framework and make a framework that deals with this. So this is how we're going to approach it, or how the draft approaches it. If you think it's wrong, comments. The first bit of it is don't send a notification. Where can we avoid sending a notification packet? Because we know that if we've got a notification, we've got to tear down the session. So what we really need to look at is how we avoid sending the notification in the first place and what the implications of sending that are. The second one is, okay, we avoided sending a notification, which means now we're missing some routing information, or we did something to an update that we don't really know what the scope is, so we might end up in an inconsistent state. So what we really want to do is we want to look at, can we get out of that inconsistent state without having to go to the whole process of resetting the session like we did before? Or what mechanisms can we do to make sure that it's an implementation error, or it's a bug that's not going to go away? So the second part is to look at how we get back to having a consistent network. And the third one is, there is some utility, and I really have to come back to this because the way that I've kind of sold it is notifications really bad, but now I'm saying, hey, we should restart BGP anyway. So I think we should restart BGP. If we take the assumption that there was some utility in restarting the session, then it'd be great if it was hitless, because that's really the thing we care about, right? The forwarding impact is what hurts us when the session restarts. We don't really care that there was some internal protocol stuff that was relearning those routes, but if it was hitless, we don't really notice that, and if that gets us out of the error condition, there was definitely utility to it. And then the fourth one is, like I just mentioned, we need to be able to monitor all these mechanisms, and especially in this case, because what we're doing is we're making the protocol more complicated. And when we make it more complicated, then unless we can see what's going on, then we've got a bit of a problem. So here's the first bit, which is avoiding sending the notifications. So this is this mechanism has kind of been discussed in the IETF for a bunch of time, and it kind of came from the 4x-air stuff, but it's been mentioned before. It's basically, if we've got router A here on the left and router B on the right, then router A transmits some update, and for whatever reason, router B thinks that this is an erroneous update, or it could be there is no assumption as to which side thinks the bug is on and which side the issue is on. Then, but we've got a case where we've got an erroneous update. As long as we can determine what the prefix is, what the NLRI in that information in that update packet was, then we can say, right, that guy's advertised us some new routing information, but there was something wrong with it. So what we'll do is we'll just won't trust that prefix or that set of routing information from that router, and we treat it as though it was withdrawn. But the key thing here is now if we do this, we don't have to send a notification, because we've kind of said, right, we're not going to use that subset of the routing information that you've given us. We don't really need to tear down the session. This gives us a way to be able to avoid having to send one. And the thing that we do have there is, though, router A thinks it's advertised some prefixes to router B, and B has not accepted them, but A has no real way of actually working out that they weren't accepted. So we've got some inconsistency across those two peers. And if you think that where it might be a more specific or so, then you might end up with either router B has no path, has a loop back to some other point which just forwards straight at it again. Or the other thing that it could be is that now we've just treated this as a withdrawal, and if we didn't have another path, we're black holing traffic. So this is obviously suboptimal. So we compromised on the fact that the topology is consistent, but we've compromised due to the fact that now one set of routing information is inconsistent, not the whole session. We haven't lost reachability to 99.9% of the table that was fine. And there's existing work in the IETF at the moment. NK Chen from Cisco has put together an eBGP errors draft, which includes the optional transitive piece of work that was for 4x-ASs. But we need to extend this to cover iBGP, because as my kind of use cases kind of pointed out, I care a lot about iBGP, and I think everybody does, because that's where I'm making quite a lot of money. Or that's where I'm making margin. Let's not assume I'm actually making money. So the second thing is we've got in this case where we've now got an inconsistency across two BGP speakers. We need to look at, can we get out of that? Because obviously we don't really like the fact that we've got a forwarding loop or we're black holing traffic, because that's not what we're here for, right? We're here to forward packets. So can we push some way and make sure that we re-request the prefix or relearn that routing information to be able to now restore consistency? And so the same kind of mechanism as before. It's maybe we've got some with the router A and router B. We've got this withdrawn prefix on router B, and we can look at there's different ways to request that prefix, right? So the only one that's there in the standard right now is a root refresh. So which is fine, but obviously there's a lot of load there, and that will leverage the same kind of update packing and that kind of code that was used in the first place maybe to advertise to us. So if we can go and ask with a filter, I just want this prefix again, please, then what we'll get there is we get that, maybe we can leverage a different code path, or we can re-receive that prefix. And we knew what the prefix was because we could pass the NLRI, because otherwise we couldn't have treated it as a withdrawn set of reachability information. The other way we can do it is we can go and ask for the whole RIB, and Keir Patel from Cisco has put together a draft that gives us a consistency. It gives us a start of re-advertised RIB and an end of re-advertised RIB that then lets us work out that actually this was the whole set of routing information that we should have had. So these two work items really do answer this kind of problem. We can now re-request a single prefix, or we can re-request the whole RIB. We give ourselves a chance to get back to being consistent. So now, okay, we've got to kind of think about what did notification give us? What was in the standard? What's the motivation to do notification? And there's kind of two. There's one that we don't want to propagate this routing information any further, so we terminate the fact that this router over here might be inconsistent. It might be in a state which is not trustable. So what we do is we tear down the session and we don't learn that routing information anymore. But the other thing that it gave us was it gave us a way to reset the numerous bits of state that sit with a BGP session. So there's a bunch of things, it's like it's a TCP session to start with. So we've got some state that we're maintaining there. So what we get by doing a notification is we get a chance for both speakers to rebuild all those structures to be able to have a chance to bring this session back up. But what was the thing as operators we didn't like that? It's not really the fact that the prefixes were relearned. It's not the bandwidth or the CPU maybe for that re-exchange to happen. It was the fact that during that we had no forwarding for that set of prefixes. So really what we want to do is we want to have a forwarding plane not affect the forwarding plane while letting a restart happen. And we kind of have a mechanism for this already, right? It's BGP graceful restart. But we're just kind of talking about, hey, let's take that because it seems like this was a good way to get out of errors. And in general, we don't have these errors that go on and when you've got a notification. So can we use this mechanism and extend it? And there's a draft in there that's called soft notification, but it expired back in 2006. So we probably have to have a look at that and see, can we just take the graceful restart mechanism and kind of fit it around round the error handling kind of case for it. But there is a bit more work required to revive it. So the final thing, and I kind of struggled with how to discuss this, because it would be nice to discuss it ongoing through what the monitoring mechanisms we would need is the monitoring. So at the moment, if your NOC gets a trap of this BGP session is down, then that's quite visible to them, right? And the other thing is, if you've got a forwarding failure, you're going to get a phone call or so. So your NOC is going to know about these mechanisms right now. It's quite easy to do so. But if we start doing things where we suddenly got one prefix that's not accepted on this session, I don't know about you, but I think that then is a lot harder for my first line guy to not escalate to the second line guy to go, well, the BGP session's flapping. I don't really know what it is, but I can see this. If he goes, oh, I don't really know, I can't see the prefix here, I can see the prefix here, and there's no real mechanism to go, actually there was an error on that prefix, then that starts to make things pretty difficult to deal with. So, the other problem is we've got two speakers, and on either side of them, we might take some action on one, and we've got no way of telling the other one that we did something. Whereas notification right now flaps at both sides of the session, right? So what we really need is we need some way to be able to have both sets of NOCs look at their router, or both people, both maybe even teams or your operator look at both boxes and know kind of what happened from each one's perspective. Kind of how we do now. And there's a couple of drafts. There's one that Dave Freeman and Tom Scholl and I think Richard Steenberger are working on, which is an advisory, which is a free text way to be able to propagate messages between two peers, but it's quite an extendable draft, so we can look at, right, okay, what do we want to propagate part of the packet? Do we want to give what visibility do we want to give to the other side? But at the moment, we don't have any mechanism by which we can propagate that information between those two speakers. And really, for us, it's much better if it's in band for that kind of lightweight protocol, because otherwise we get crazy suggestions like, well, we should just syslog at each other. And I don't know about you, but the security implications of opening up syslog to another company are somewhat concerning to me. I've already trusted this my peer, and we've got some COP or whatever it is that's controlling that messaging. So an in-band mechanism is very useful for that. There's also a secondary draft that's a bit more detailed, gives a bit more information, which is diagnostic, and that's come out of Cisco, and it's got a lot more specification, but it starts to be able to ask, well, tell me about what this state or what this count is on the prefix. Then the other thing is, we know that we have a lot of BGP analysis mechanisms, right? So we've got things like RIPE, RIS, and those kind of tools. This protocol is so key to us as internet operators and as any kind of IP operators that we like to monitor. It's good. We should be looking at it. So it kind of almost justifies the fact that we use another protocol to look at what the state across two boxes is. And if it's an important enough adjacency, the control plane overhead perhaps to do that separate protocol is really worth it, especially as now independent errors in your monitoring protocol become independent of the session itself. So there's a draft in the GROW working group in the IETF that is BGP monitoring protocol. It starts to define a protocol, how we can look at that kind of information out of band to the session. But I've talked through a bunch of mechanisms, kind of have to think about how they fit together. And so if we start on the left-hand side, we get an erroneous packet and we treat it as if we can determine the NLRI, we treat it as withdrawn. And then if we've done that, we can optionally go and ask for one-time prefix, but it'd be nice if we could ask for one-time prefix, because that would mean that we don't have to go through the whole load of re-advertising the RIB. And then if that didn't work, then we move on and we can say, okay, the next thing we do is re-request the whole RIB from you. Give me the whole RIB again, and let's see whether we get out of this error condition. If we still don't exit that error condition, or we couldn't treat it as withdrawn, then the only real option we've got is we don't know what this limit was in terms of routing information that was wrong. So if we do a hitless session reset, then maybe we get another chance to get things consistent again. But then we get the error after our hitless session reset, and we just get into a loop, because what do we start doing? And the other problem is, what happens if there's multiple prefixes that have got errors? How do we handle this together? So this complexity is, I've tried to discuss it in the draft, it's getting a bit into implementation detail, but the kind of recommendation that we're trying to do is, this needs to be tracked per session, because if you track it per prefix state sounds horrible to me. It sounds like it doesn't scale, and it sounds like an implementer's nightmare. If we do a per session state, then what we can do is we can say, actually, there's something wrong with this peer, but it is stable enough to get the session back up again after we've reset it. Because if the box is completely broken on the other side, probably when I try and reset the session, it's not going to come up again if it's in such a bad state. And at that point, yeah, this box can't bring a BGP session up. It's broken. But otherwise, if we mark the session as bad, we've got some subset of the routing information that we're missing, but maybe we're happy with that, because what we've got there is we've got we can flag that to our operator. We've got the monitoring mechanisms to make sure that now somebody's going to look at this box. It's in an inconsistent forwarding state, but let's let a human make a decision about how important this is, because if it's really important, maybe you're going to turn the session down. But at least for the time period while you were looking at it, you had forwarding for the rest of the table that wasn't broken. So why am I standing here? I've kind of explained this, but as operators, we are the people that deal with the fallout of protocol issues. So I guess there's a bunch of people in this room who do on-call, and you get woken up at 3 a.m. when BGP is broken to something important. And what that means is that, personally, I have a big motivation not to be woken up at 3 a.m. I like sleeping, thank you. So and your vendor might get called out, but it's probably a guy who's on shift, right? So we really should, it's really great if we can define as operators why this is broken and why it should be more robust. And the other thing is, it costs operators more money, right? We don't get an SLA on software from a vendor. So we get this bug, and really what happens is we just push the vendor to fix it. But it's probably us that are paying service credits out based on the fact that the service was broken for however many hours it was broken for. So if we've got an agreed operator-recommended approach, it's really easy to kind of stand up and go, well, this is what we want, and this is a customer view of maybe into the vendors, but also it gives us a input into the standards process where the two views, the implementer and the operator view, can be really well determined. So I'm really, really seeking questions, comments, and review of the draft. It's the URL is just up there, so it's a bit long. It was kind of hard to come up with a decent title, so that was the hardest bit of writing, I think. So hopefully, if you've got time to review it, or if you've got interest to review it, that would be much appreciated. And the other thing is, I've put together this feedback form because we've kind of had some discussions I've had here this week have kind of indicated that there's a big gap here. There's a big IETF to operator divide, and it'd be really great if we could start looking at the way that we fit that together and see what. So if you've got ongoing interest, there's a checkbox on the form, and I promise not to spam you. But if you give me your email address, I will try and get in touch once we've worked out how that bridge might get gapped, how that gap might get bridged. And thank you very much for listening.
Hi, Dave Friedman from Clarinet. Have you given any thought to the multi-session approach that's going through the IDR at the moment with regards to how sessions can be separated based on the AFI and SAFI, such that if one session breaks, the others are preserved?
Yes, I have. I've got a backup slide about this actually, because it's one of the common questions. The problem is with multi-session is that at the moment it's not really standardized and doesn't really fit in that well because it's not single port. We end up with this crazy situation where we've just kind of moved the BGP session out to some other port, and that then doesn't fit into your control plane policing or that kind of rate limiting. But really, and at the moment, you've probably got in your network, unless you're accidentally running it, you're probably running multiple AFIs on a single session. So if we have an error there, then what we can do is send a notification for that session. But even in the case where it did only hold one AFI, it still breaks all the other prefixes that were in that AFI. And I work on quite a big L3 VPN network, and so the motivation to try and separate topologies, I don't care that there was an error in VPN v4, I care that there was an error in one topology maybe. So unless I can separate that out to a single topology per session, rather than a single SAFI or AFI, then it doesn't work. But this is a scaling nightmare, and I think if I said, oh, you should work out how to build my topology map based on what RTs are imported everywhere, then build a session per connection, then I might get shot by a vendor. So I don't think it solves the problem, but it helps.
Excellent.
Thank you.
Thank you, Rob.